Hello, grade 12 students. This question from application of derivatives. It's a very important question. This is a PYQ which has come in boards also. Let's just try to make it simple. So this is basically giving a scenario in which a overspeed violation detection system has been installed on the poles, like as shown in the first figure. And now there is a scenario given that on a particular pole of height 5 meters, there is a camera installed. And then it detects a car traveling away from the pole at a speed of 20 meter per second. So at a speed of 20 meter per second at any point x. So we have marked the distance x here. From the base of the pole, the angle of elevation of the speed camera from the car is theta. So few things are given. So the height of this pole is given. And when we complete the triangle, the right angle triangle, this distance from the base of the pole, let's say I name it A, B, C. So this is X. Now the speed is 20 meter per second for traveling this distance. So the first thing which they're asking is express theta in terms of the height of the camera installed on the pole and X. So it is very simple. They are talking in terms of the perpendicular and base. So I can say that tan theta is equal to 5 by x. So the first part is really sorted. Theta is equal to tan inverse 5 by x. Now the second part says find d theta by dx. Now d theta by dx. In order to do this, we will again do the differentiation. So d of tan inverse 5 by x along with dx. Now what happens is, this is an inverse trigonometric function. So what will be the derivative of tan inverse x? It will be 1 by 1 plus x square. So this will become 25 by x square. And then as per the chain rule, so when we derivate the angle also, so what do we get if we derivate 1 by x, right? We'll get minus 1 by x square. And then for 5 by x, we will get minus 5 by x square. So this is your d theta by dx. So I can write it here as, so when you simplify this, take the LCM, this becomes x square plus 25, this x square, and both the x squares get cancelled actually. So d theta by dx will become minus 5 by x square plus 25. So the second part is also sorted. Now the third part, when the rate of change of angle of elevation with respect to time at any instant, that we have to find. So basically they are talking about finding rate of change of angle of elevation with respect to time we have to find. And let's say when this distance, which is x given, has been 50 meters. So let's say when the car has moved 50 meters away. So first thing we have to take care here is that if the car is moving away, so we should know that when the car is moving away, right? So the angle theta is actually decreasing, right? If we are moving away from the pole, so the theta, the angle of elevation, so its values will keep on decreasing. So basically it's a decreasing function. So we will use that now. So let's see what is given in the question. Now d theta by dt. So if you look at it, it's a parametric function. So theta changes with respect to x into dx by dt. If I do, I will get d theta by dt. Now the question is, what is dx by dt? So if we observe here clearly, the speed is given 20 meter per second. So that means what? That is basically, if velocity is given, so that means it is dx by dt for this distance. So I can write it as d theta by dt is equal to minus 5. This we already calculated from the first part, into x square plus 25 into 20. So this becomes minus 100 by x square plus 25. So the only two things which we had to consider here was d theta by dt as d theta by dx into dx by dt, and also to know that the speed is nothing but dx by dt, which was given to us. Now, one more thing, they want that particular value which is at 50 meter away. So once we get the d theta by dt as minus 100 by x square plus 25, I have to just substitute here for x as 50, which will give me minus 100 by 50 square, 2500 plus 25, which is 2525. And this will come out to be minus 4 by 101 radian per second. So units, if in the next part also it is given that if the rate of change of angle of elevation with respect to time of another car, let's say there is another car, but that car is also at a distance of 50 meter away from the pole, but it is making an angle of 3 by 101 radians per second, and we have to find the speed of that car. So let's see. Now in this particular OR case, basically they have given d theta by dt of another car as minus 3 by 101 radians per second. Why I have taken negative here? Because I know that the angle of elevation is a decreasing function with respect to time. So using the same concept now, d theta by dx into dx by dt will give us minus 3 by 101. So d theta by dx, the generalized derivative I already have as minus 5 by x square plus 25 and into dx by dt, because I don't know what is the car speed of the second car. For the first car, they have given the speed, we calculated the angle. Now they have given the rate of change of angle. We have to calculate the speed of the car, and this is how these systems work actually in practicality. And distance still remains as 50. So we have to just substitute in the values, let's say minus 5. Again, it will become 2525 into dx by dt is equal to minus 3 by 101. And rest is just the calculation, children. Dx by dt. This can be written, minus and minus will get cancelled. This can be written as 1 by 105 is equal to 3 by 101. Or I can say that dx by dt is equal to, this will be 5 times. So this is equal to 15 meter per second. I hope the question is clear. Thank you so much, children.